Welcome to the manufacturing project of a professional custom mini refrigeration system. Starting with the heart of the system, the refrigeration compressor is fixed on a vise and powered with 220 volts for testing. Pressure is tested using a balloon attached to the discharge pipe. The balloon inflates quickly, proving the compressor's compression ratio is excellent. The internal reed valve system is completely sealed. Disconnect the power and remove the compressor from the vise. 1. To move on to the mechanical stage, measuring galvanized steel square tubes. The dimensions require high precision for the structural base. 2. A high RPM Makita angle grinder cuts the metal, creating bright sparks at the cutting point. 3. 4. Simultaneously cut the crossbars and vertical pillars, preparing for the structural assembly process. Assemble them on a flat steel table. A red, magnetic square helps accurately position the 90-degree right angles. A technician uses a semi-automatic MIG welder. Deep welds minimize slag and prevent thermal distortion. The bottom crossbars have been firmly connected. The machining process requires meticulousness at every joint. The vertical pillars are positioned and tack welded one by one. This frame plays a core role in bearing the static load. Continue assembling the top base of the frame. A solid, the metal frame will eliminate the vibrations of the compressor. To complete the corner welds to reinforce the load-bearing capacity, the spatial structure has taken its complete shape. After cleaning the welding slag, the frame is taken outside. Apply an even coat of high-pressure matte black ATM spray paint. This polymer layer prevents oxidation, protects the metal, and gives the module a professional technical appearance. 1. Move on to fabricating the main evaporator. Recycle an 8-liter stainless steel thermos with a dispensing valve. 4. Turn the thermos upside down and use a flathead screwdriver to pry it forcefully, breaking the locking tabs to detach the load-bearing plastic base. 1. Access the internal insulation foam layer. Remove the valve assembly by carefully unscrewing the water faucet by hand. 2. Use a rigid steel ruler to scrape into the polyurethane foam layer, breaking the bond between the insulation foam and the stainless steel shell. 3. Successfully pull the inner stainless steel core out. This core will serve as the water tank for direct heat transfer. 2. Continuously rub the core surface with sandpaper. The goal is to completely scrape off any residual foam adhesion. 3. The exposed metal surface ensures good heat transfer, ready for the pure copper tubing to be wrapped around it. Start wrapping the copper tubing around the outside of the stainless steel core, creating a direct evaporator enveloping the tank. This manual operation requires consistent pressing force to press the copper rings tightly against the stainless steel tank wall. A specialized tube cutter gently rotates to cut off the excess section, ensuring the cut is flat and undistorted. 2. Proceed to apply specialized thermal insulation aluminum tape, completely covering each coil of the copper tubing. 3. Tightly smooth the aluminum tape edges to press the gas pipe against the shell, increasing the heat exchange surface area. Tightly wrap the entire copper tubing block with silver tape. The heat absorption efficiency from the water will reach an optimal level. At this point, the condenser around the tank has taken shape. The aluminum tape wrapping securely fixes the heat exchange network. On the black plastic bottom cap, the technician makes marks and uses a drill to create 2 holes for the gas pipelines. Insert the newly wrapped core assembly back into the outer stainless steel shell, creating a sealed space that isolates it from the ambient temperature. Proceed to reassemble the dispensing valve, carefully placing the rubber gasket into the correct groove. This is a water leak prevention technique. Tighten the nut inside the tank wall, ensuring the hydrostatic pressure won't cause leaks when filled with 8 liters of water. Precisely thread the 2 copper pipe ends of the cooling coil through the pre-drilled positioning holes on the load-bearing plastic base. 4. Manually press the tabs to firmly close the plastic base cap onto the stainless steel shell. The module block of the water cooling tank is completely sealed. Set the tank upright and open the lid to check the inside. The shiny stainless steel surface is ready to hold the cooling solvent. 1. Return to the electrostatic painted steel frame. Install an industrial, moisture-resistant gray MDF board at the bottom tier of the stand. 2. A cordless drill, combined with a self-drilling screw, penetrates the steel layer, securely fixing the bottom board to the crossbars. 3. Tighten the screws at all corners to set a solid floor. This flat floor will bear the entire load of the compressor. Continue screwing to secure the second MDF board onto the top surface, finishing the spatial chassis frame. Complete the top cover with self-tapping wood screws. The 2-tier spatial chassis is ready to bear the load. A quick transition. The creator makes a purchase from a car, buying an aluminum finned condenser coil. Installing the condenser into the lower compartment of the frame. The aluminum fin structure maximizes the heat dissipation area. Using plastic zip ties to tightly secure the U-shaped headers. Securing it, firmly attaching the condenser to the steel frame's legs to prevent vibration. Positioning the refrigeration compressor next to the heat-dissipating condenser. Screwing the rubber shock-absorbing feet down to the board. Using a twist drill bit to make technical holes right through the tabletop, preparing the path for the gas-carrying copper pipe system. Fabricating a capillary expansion tube from a small copper pipe, tightly coiling it by hand around a PVC pipe core to form a spring shape. This capillary tube acts to reduce the refrigerant's pressure, creating a pressure difference between the condensing and evaporating chambers. Placing the stainless steel water tank wrapped in the evaporator coil onto the table, threading the 2 ends of the copper pipes through the pre-drilled holes. Proceeding to bend and connect the compressor's discharge pipe, using a high-temperature gas torch to melt the silver brazing rod. The red-hot weld penetrates deeply, completely bonding the metals, successfully connecting the high-pressure line from the compressor to the condenser, attaching a filter dryer to the condenser's outlet to protect the system, brazing the spring-shaped capillary tube to the filter dryer's outlet. Brazing the other end of the capillary tube to the evaporator's inlet line. The closed refrigerant circulation system has been fully connected. Installing a high-speed axial fan behind the condenser. This fan forces the airflow to rapidly cool the condenser, preparing to charge the refrigerant, connecting the piercing valve to the R134, a refrigerant cylinder, the standard for small cooling systems. 1. Connecting the blue gas hose to the compressor service valve. Opening the purge valve to expel air, preparing for the refrigerant charging process. Connecting the 220 volts power supply. The system officially starts up. The axial fan and compressor operate in sync. The R134, a refrigerant, is drawn into the system, continuously circulating through the evaporator and condenser. Closing the stainless steel tank lid to ensure complete insulation, preventing heat loss to the external environment. After reaching the design pressure, the technician closes the valve, removing the gas cylinder and charging hose. Beginning the practical test by directly pouring pure water into the 8-liter cooling chamber. Tightly closing the double lid system to prevent spills and provide insulation. The heat, absorption, and exchange process begins. Using a probe-type digital thermometer to directly probe the temperature of the water inside the chamber. The sensor records an extremely rapid temperature drop, plummeting from 30 degrees Celsius to below 6 degrees Celsius. The excellent cooling efficiency proves the design of the copper tubing wrapped in aluminum tape works perfectly. Dispensing the final product through the tap. A mini beverage cooling system, crafted to perfection.